Okay, so we just took the integral up here. You guys can pause the video and take a look. Sorry, we're starting a little late. Just to review what we did. We called u cosine. We took the derivative, solved for dx, substituted our du back in, our signs divided out, leaving us our u cubed problem. U cubed, we can integrate u squared. We can integrate u squared pretty easily by n plus 1 over n plus 1. This is here. Then we plug back our u, and we're good. Now, to just again prove that this is true, we're going to take the derivative, d over dx, negative cosine cube x over 3. I'm going to rewrite this part slightly by writing the 1/3 in the front to make it a little easier. Let's see. Now, when we took the derivative, what do you take the derivative of first? The cubed or the cosine? Do you take the derivative of the cube first or the cosine? The cubed or the cosine first?
The cubed.
The cube, perfect, right? We go outside in for power rule and chain rule. So chain rule first, it's going to be negative 1/3. Bring down the 3, and we're left with cosine minus 1, cosine squared x, followed by chain rule. The derivative of cosine is negative sine. And the derivative of c goes away. That's 0, because it's a constant value. Rewriting this, 3's divide out, the negatives divide out, and we're left with sine x cosine squared x, which is back to where we started from. So u substitution is pretty nice. It can be really, I would say, fairly useful oftentimes. But if you look at my problem on my left, number 1, cosine squared, that problem isn't a u substitution problem. Problem number 1 is not a u substitution. So there are a couple of rules, and the person who wrote this, a teacher in Diamond Bar, he wrote it as pretty simply, these are even and odd powers. If you have an even power or you have an odd power, we're going to either use Pythagorean theorem to substitute, or we're going to use what we call power reducing. And this looks a little funny because Microsoft messed up with the format of it. But here are some identities that we need to worry about. Sine. Here's identities you guys want to know. Sine squared x is equal to 1/2, or rewriting, 1/2 of 1 minus cosine 2x. And sine, cosine squared x is equal to 1/2, 1 plus cosine 2x. This is called power reducing. Do you guys remember power reducing from last year in pre-calc? It was one of our trig identities we think to prove. The way power reducing works is you take the exponent, you say, I don't want to write this as exponent. I can write this as a cosine, which is not an exponent anymore. Hey, 2 is an exponent. I don't want exponent. We write it as a not exponent. You guys might have seen this function also written slightly differently as 1 minus cosine 2x over 2, or 1 plus cosine 2x over 2. You guys remember seeing these slightly at all before? Hey, 15 people. Hi, 15 people. No, is it kind of new for you guys? So then if it's new, then straight memorization. Just straight memorization. So okay. So knowing this idea here, we can do this problem over again. Now, why can't we use U substitution on this previous problem? If I go ahead and try it,
Thing cancels out.
like if I integral of cosine squared, let's just do cosine squared x dx. If I say u is cosine of x, du is sine x. Do you guys see any sine x to cancel out? No, right? So it's not going to work. What if I say u is equal to cosine squared x dx? Well, du is equal to 2 cosine x sine x. This is even worse. So none of these two u substitution ways work. Could I rewrite this? If you want to rewrite this as integral of 1 over secant squared x, well, secant squared x is an identity that we know, but that's on the bottom. Our integral is integral of secant squared x on top. That's tangent. So that doesn't work either. So as we are learning different methods to deal with different types of integral problems, when it comes to even and odd, there's a method for it. So if it's even, meaning the exponent is even, let's do cosine of x squared. This is even. If I wrote cosine cubed x, this would be odd. Okay, that's odd. We have to use this substitution. So this can be changed. Cosine squared x is equal to 1/2 1 plus cosine 2x. Now, just for your memory's sake, how do you know which one to use? If you look at it up here, they both look so similar. They both look so similar. But you notice one's a positive and one's a minus. So if you remember, the general way is 1 plus or minus cosine 2x over 2. The main difference is actually if it's cosine, if it's cosine here, if it's cosine, hey, it's going to be positive because cosine becomes cosine without any penalty. But if you're sine, it's always going to be in the minus version because it costs you. Sine doesn't look like cosine, so it's negative. Cosine does look like cosine, so it's positive. So if you haven't memorized that before, that could be a hint. Cosine stays positive, but sine becomes a negative. So how does that help us in what we're going to do here? Well, let's write it out. I'm going to write 1/2. I'm going to go 1/2. We said it's cosine, so cosine stays positive. That's 2x dx. The 1/2 gets kicked out because it's constant, and we end up taking the integral of two separate integrals. And Ms. O'Brien probably has taught before, if you have a plus sign, you can separate this into two easier separate integrals. Integral of 1 dx plus the integral of cosine 2x dx. Is everyone okay with the split? You don't have to write it, but it's something that should be going on in your head. And you don't have to write it, but again, you should be doing it in your head. The integral of 1 is pretty easy. That's just going to be x. Now, over here, our identity doesn't say the integral of cosine 2x. It's just a cosine of x. So we're going to have u substitution here. U is equal to 2x. Du is equal to 2 dx. Solving for dx, and that's going to be du over 2. So when I plug this one back in, on the side note, this would be the integral of cosine 2x became the letter u, and dx became du over 2, which means we have a constant. I'm going to keep the constant out. So it's going to be a plus 1/2. And the integral of cosine u du is just cosine. Oh, sorry, it's a sine. And then instead of writing u, I'm going to plug back 2x. And don't forget to write plus c. Just to prove that this is right, like I like doing all the time, let's go ahead and just take the derivative. We're going to take the derivative of this whole thing real quick. The derivative of x is 1. The derivative of 1/2 sine 2x, 1/2 is a constant, so plus 1/2. The derivative of sine is cosine 2x. Chain rule, derivative of 2x is 2. 2's divide out. We're left with 1 plus cosine 2x, which is what we should have gotten. Okay? Just to prove to you that we did the integral correctly. So my question is, was this integral that difficult? Was it hard for me to take the integral of just 1? Not really. Was it hard for me to take the derivative of cosine? Not really. The 2x, that involves some u substitution, but that 1/2 that we brought back over, the du over 2, right here, we needed that because of chain rule. Because when I took the derivative of sine 2x, the derivative of sine 2x, it's 1, so it's 2 cosine 2x. This 2 had to come back.
Mr. Ko.
Yes.
Do you put the c in the parentheses to be multiplied by the 1/2, or is
Yeah.
it
Well, in the end, it doesn't matter because 1/2 c is just another c.
Sure, but for like the answer's sake.
I would say you could leave it out, but if you saw the way we did the math here, this is all times 2, so the whole answer must be times 1/2 multiplied by 1/2. So if we're doing it right, like the math way, you're supposed to write like this.
Okay.
But we know it's just going to be plus c at the end, which is also fine, I guess. So it's 1/2 x plus 1/2 sine 2x and then plus c. This is just our like c 2.0 upgraded version.
Sine 1/4.
You know what? You're a genius, Omar. Thank you for paying attention and playing.
Video games at the same time.
What video game was that? Terrace?
I'm actually watching Age of Empires live stream.
You know what? That's the most boringest thing in the world. What is wrong with you?
It's the tournament.
Okay.
Best players play.
Gather resources. Oh, look, he's gathering gold. Oh no.
We have our fun, okay?
Okay, any other sorry, Sadie. I didn't catch your message, but thank you. Okay. And that's my answer. It's kind of ugly, but it works. It's better than me saying I can't take the integral. Now, for all these problems, they're like this. They are more difficult. Will you end up with 1,000 of them on the AP exam? Well, apparently on our current AP exam, you won't get any of these.
Mr. Ko.
Yep.
Does that say C to the 20?
C 2.0. C 2.0. Second version.
Oh, okay. I was like, that's not a thing. Okay.
Yeah, C 2.0. Because this C, honestly, isn't the same as my original C. But it's still a constant, regardless. Okay, so will you end up with a lot of these problems? No. But a lot of times in math, you're learning these skills for certain situations. And certain situations where we can't use U substitution, and it's an even exponent, we use this rule. And this rule here, which you never thought you would use again from pre-calculus, came back and haunted us. Yeah. Kind of sad. Okay. Let's go ahead and do another one of these problems. Oh, well, actually, no, we should finish. Well, we'll do problem number 4, which, yeah, because we kind of skipped number 1. We did the easier version, but I don't want to end up doing it again because it's practically all the same steps. So let's go ahead and do number 4. 4 goes integral sine squared x over 2 dx. Now, as we mentioned before, since it's squared, this is an even function. So we're going to be using our identity sine squared let's call that u is equal to 1 over 2, parentheses 1. Since it's sine, it's a minus sign, cosine of 2u, where u is going to be x over 2. So sine squared of x over 2, that's what we have, is equal to 1/2 1 minus cosine of 2 times x over 2. And lucky for us, those 2's divide out. So it'll be 1/2 1 plus cosine of x, which I hope is easier.
Fine, that's right.
You are a genius again, Momar. Thank you for catching me. I do appreciate it. Not being sarcastic at all.
I'm pretty sure you're sarcastic.
No, I really am not. You know, it's hard being sarcastic all the time and then being honest and having people believe you.
Life is so hard, Mr. Clark.
The CCP.
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 It's racist to call the Chinese coronavirus.
Yes, I can see how other viruses like Ebola Zaire, when they call it Ebola Zaire, by naming it after a location, or Ebola Marburg, can be racist too. Imagine if they stopped calling things like, "Oh, that's a Japanese car. That's an American car." That's racist.
No, people care about car.
All right.
Jack
Well,
Cobb-
we'll see what. What? Okay, back to math. Yeah. Thanks. Yeah. Sure. I'm gonna watch this video again. Who said that? Okay, so changing it, this becomes parentheses. I'm gonna save myself some time. I'm gonna throw the 1/2 out because that's a constant. 1/2, 1 minus cosine of x. And it turns out this problem is actually a lot easier. We can take the integral of 1 fairly simply, and when we know what the integral of cosine is, I'll save us time. So 1/2, parentheses, integral of 1, going backwards is just x. Integral of cosine, I'm writing negative. Integral of cosine is sine. And then plus c. And we can write this as 1/2 x minus 1/2 sine of x plus c. 2.0. Yeah, 2.0.
If you left the 1/2 on the outside, would it still be considered right?
Yeah, what happens is it's all about how much you want to simplify your equation. But if this was a multiple choice, you would obviously see that you distribute the 1/2. If this was a free response question, there is no reason that you had to distribute that 1/2. Free response questions don't care that you can multiply 1/2. And our answer is number 4. Now, a lot of these questions we see here are like that. Now, let's look at the odd questions. Let's look at number 2. Now, even if the AP exam might not cover integration, many of you guys are going to a 4-year college, and if you guys do pursue a major that would require you guys to take that next level calculus, I'm not even sure if colleges would accept this AP score then, anyways. But whatever the case, when you're taking calculus on the college level, they're expecting you to know all the steps already. So if you can learn it now, when you're in college taking the class over again or taking material with this, like you won't be behind. You won't be that kid who says, you learned this in high school? I didn't. I didn't know what was going on. The coronavirus. Not like you would say that, but let's do this one. 3x. Okay, so now this is odd. Now the thing with odd, our even value doesn't work. So we're going to actually rewrite this as integral of sine x, in this case 3x, I'm sorry, times sine squared 3x. And there's a particular reason why we're doing this is because we're going to change this problem here using another identity that we learned in pre-calc and geometry actually. And this we're going to use our Pythagorean. Sine squared u plus cosine squared u is equal to 1. is remember sine squared plus cosine squared is equal to 1. Am I going too fast? Please let me know if you guys have any questions. I do talk fast. Miss Yagi's class doesn't know, but I am. Hey, Jack! Thanks for joining us. Thanks, Hagar. Good job for rounding him up.
He's been here for like 15 minutes.
He's been here the whole time.
You know what?
Increase.
I do math for me, not for you. Okay, so I don't care who's here. I'm doing this.
Sassy.
Hey, Jack.
Yikes.
Okay. Now, in order to use a sine squared, you might be saying like, why are we doing this? Why can't we use u substitution? Again, if I call u as sine of x, derivative of sine x is cosine, and there is no cosine here. There is no cosine here at all to divide out. So that would have failed. So we're trying to find another way. And oftentimes it's being clever. Like Mr. O'Brien gave you guys a list of problems, and yesterday I posted a solution for I think 18 and 19, and it's just, oh, is this still working? Oh yeah, you guys still here, right? 18 and 19, and it was just being clever on how we did the problem and not chickening out too early. So someone became clever and said, hey, why don't we change sine cubed to sine and sine squared? And we can change sine squared using our Pythagorean. Sine squared u is equal to 1 minus cosine squared u. So we're going to use this to say, hey, if u was 3x, sine cubed of 3x, sorry, squared of 2x, squared of 3x is equal to 1 minus cosine squared of 3x. And we're just going to plug it back in. The integral of sine 3x, substituting 1 minus cosine squared 3x in. You might say, Mr. Ko, this looks a lot more messy. And why are we doing this? Is because when I distribute, you'll notice something, maybe. I multiply 3x, sine 3x to the front and the back, the 1 and the cosine. Do you know what the integral of sine is? We do. We can take the integral of sine. We have to do some u sub, and some of you guys hopefully are starting to catch on how this u sub is going to work. U is equal to 3x, du is equal to 3 dx, dx is equal to du over 3. Our cost is just, we got to bring back a 1/3. Integral of 1/3 sine of u du. I should write that out for you guys, right? Sorry about that. Let me write that out. Sine of u, because we called it u now, and the du would have been du over 3. Rewriting it, 1/3 integral sine of u du, and we know what the integral of sine is. It is negative cosine. Plugging back the u of 3x. Done. We were able to take the integral. On the right side, we're stuck with sine cosine. And this is back to u substitution. If I say u is equal to cosine of 3x, du is negative 3 sine 3x dx. Dx is equal to du over negative 3 sine 3x. Hey, look here, 3x and 3x. We're able to get rid of that now. So because we rewrote this using an identity from trig, we were now able to, for part 1, easy integral. Sine becomes cosine. Sine cosine squared, the second part, I can do u sub now, something I couldn't do previously. So let's write that out. So this is minus the integral of sine 3x. We substituted cosine for u squared. And then we're going to swap out dx for du over 3 sine 3x, that being negative. If you see, the sine 3x divides out with the sine 3x, and the negatives become positive. So we're left with 1 over plus 1 over 3, the integral of just u squared du. Go ahead, take a look at that, making sure that you see I canceled out the sign. I moved out the 3, but we're still having a u squared there. Cool thing about u squared, that's just power rule. Power rule is n plus 1, 2 plus 1, plus 1 over 3. U cubed over 3. Oh, sorry, I need to bring back another. And then we're going to write that's a u cubed. And we're going to substitute it back in. That's going to be cosine cubed 3x, because we plugged in u back in, just to save time. And then plus 3. Oh, sorry, not plus c. I'm sorry, plus c. Rewriting this a little bit. Negative 1 over 3 cosine 3x plus 1, sorry, cosine cubed 3x over 9 plus c. Now, if you persevered through a problem like this, man, good job. Honestly, this is a lot of work. This is a lot of times where I said, "No, what? I just want to give up. This is too much. Let someone else figure this out." But you gotta realize when you're in college, you're gonna be going through struggles like this, problems, a lot of critical thinking, moving stuff around, rewriting something that you know already. And this was the answer for, what's that number? What was this, number 2? No. Oh, number 2, yeah. Look at the answer for number 2. That looks like what we wrote. Winning. All right. I feel smart. Of course, I've done this like 1,000 times now. Now, you really have to do this yourself. You have to do it over and over again. Hey, Sergio. Thanks for joining us.
He's also been here for so long.
Mr.
he's
Co,
been here
I've been
for a
here
while.
forever.
How do you
Oh,
know
well,
this?
This is
Sadie? Are
just
you looking at
offensive,
people?
Mr. Coe.
I'm very offended, Mr. Co.
As you
Again,
should be.
out of the,
I still love you though, Mr. Co.
oh, thanks, Sergio. Out of the 30, like 7 kids that you have in your class, maybe
Like
like
2
5 of
pulled
them are
up.
here. Well, half these kids are my kids from previous 4.
Yeah, I'll
I
probably
think most
tell
of
my
the juniors gave up.
You should
Yeah.
tell them. I mean, I'm having fun.
Shay.
Glad you're having
No.
fun, sir.
So back to math, yeah. If you look at these problems here, I'm going to go ahead and go through them quickly. This really only works with sine and cosine, whether it's cubed or squared, even or odd. And that's the thing, it's even or odd. So if you look at the problems that were given on my left side, whoops, lost that. Even, oh darn it, I need to write on this. I don't want to write it. Go away. Just copy this. See what happens. Never mind. Won't let me do it. Let's go back to what we did before. If you look at some problems on my left, some of them are, oh no, let's try it one more time. To the notes. Save. Nope, didn't save it. I still can't run it. It's kind of always. Never mind. Okay, you look at problem number 1. You notice on problem number 1, that's a squared. Problem number 2 is a cubed. Problem number 4 is a squared. Problem number 5, is that sine or cosine? Is that sine or cosine? It is not sine or cosine. So because it's not sine or cosine, it won't work. Do we know what the integral of secant squared?
Yeah.
What is it?
Tell me.
Integral of secant squared is tangent.
Oh, of course.
Of course, Mr.
Of
Co.
course, right? Everyone knew the integral of secant squared was tangent. Turns out that's just actually a U substitution problem. You didn't need to do it.
You didn't do the sneezing thing.
Yeah, yeah.
That's for secant tangent.
This is a different one, guys.
Secant tan.
Secant tangent. Thank you. That's right. Secant tangent.
Bless you. Bless you, Mr.
Bless
Co.
you,
Bless
thank
you.
you. Sorry, allergies. I mean, corona. I don't know. This goes too soon. It's too soon. Secant tangent.
Funny,
So the derivative of tangent is secant squared. Remember that the derivative of tangent. Darn it. Let's get a pen. Just a reminder. The derivative of tangent is totally off. That's why it's secant squared. The derivative of cotangent is negative cotangent. Nope, sorry. Negative cosecant squared. So it's like this is the reciprocal and this is the reciprocal, both a negative. Now, if you guys didn't know this, Miss Yagi isn't named Mr. Co, but every time you take a derivative of a co, you end up with a negative because co sucks. The derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. Negative cosecant cotangent. If you didn't know that, just let you know, because co sucks. Okay. Okay. What else can I say? Looking at problem number 7, that's squared. Looking at problem number 8, that's cubed. Problem number 10 is squared. Number 10 is tangent, which doesn't use this rule. Okay, which doesn't use this rule. Even and odd only work with sine and cosine. So for tangent, I would have to play with that. For instance, let's do a version of number 11. Let's do it without the d, with the 4x. Integral of tangent squared x dx. Now, do you remember an identity with the integral of tangent squared? Of course not, because there is none. So we cheat. We change this to tangent of x is equal to sine of x over cosine of x. Hopefully you remember that. That's our quotient identity. So if I write integral of sine squared x over cosine squared x dx, maybe I could use this. Maybe I have a different identity, and this is something we have to experiment with. If you remember, sine squared plus cosine squared is equal to 1. If I divide this by cosine, 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 this could be tangent squared x plus 1 is equal to secant squared x. So tangent of squared x is equal to secant squared x minus 1. Maybe instead of using this guy, I want to try something a little different. Maybe I'll try the integral of tangent squared is equal to secant squared x minus 1. Now, looking at this guy here, with more space. Looking at this guy, let's try u sub. Let's just try it. What's the u? Let's say it's cosine. What's the derivative of cosine? root of cosine is sine. Does sine cancel out sine squared? Is there enough? I need 2, right? So nope. So you can't be cosine. You can't be cosine. Can you be cosine squared? Try it. U is equal to cosine squared x. Du is equal to 2 cosine x. The root of cosine is sine x. That doesn't look like sine squared. So U substitution doesn't work. Darn it, I tried 2 different things already. What if I tried using this power reducing formula? Right? Well, that looked like trash. So let's go ahead and try something else. Look over here on the right side. And do we know what the integral of, sorry, oh. Do we know what the integral of secant squared is? Do we know what the integral of 1 is? The integral of secant squared? The integral of secant squared x dx minus the integral of 1 dx by separating those integrals. Integral of secant squared is tangent. And the integral of x is, no, integral of 1 is x. Turns out that's our answer. Turns out this was not the identity that we should use, but it's actually this guy here. Now, how do you know this? Just straight experimentation. Just try something. We'll end up with a lot of roadblocks. But in the end, we kind of figured it out. Okay. So maybe one method might not work. You try another method. It's all about just experience. Oftentimes, trying something, it doesn't work. If you look at problem number 3, 3 is probably one of the hardest problems on this because it's to the 4th power. And I'll just give you as a hint. You guys might want to try it. But it's going to be the integral of cosine to the 4th power x dx. This becomes, if it's even, we have to use our power reducing. And the power reducing, cosine squared x squared. And it's going to be 1 plus cosine 2x over 2. And you're going to multiply that out. And you end up with another square. And you do power reducing again. Now, if you guys need me to do that problem, I can do it. You can also find this example like everywhere on Google. If you just Google that problem, you can actually find it. But if you need me to do it, I can do it next time. But if not, try it yourself. It's a little challenging, but unfortunately, you might see it sometimes. Okay. Any questions about this new way of integration when it comes to something either is squared or cubed? Again, this is when it's squared or cubed when there's nothing else there. If you look at number 8, cosine cube x sine x, number 8, would we need this rule?
No.
Well, I'm hearing no. Well, if I choose u being cosine, that's our sacrifice. What's the derivative of cosine? Cosine is sine. Hey, that would get rid of the sign next to it. And this would just be an easy integral problem. Okay, so write it out, try it. Any questions? I'll post this on YouTube. Hopefully, I'm gonna stop recording now.